July 20th, 1969. A moment frozen in time. Neil Armstrong's historic first step onto the moon was more than just a triumph of science. It was the dawn of an era filled with dreams of lunar cities, colonies, and even mining the moon's resources. But fast forward to today, and one question lingers. Did we ever come close to making that dream a reality? Or was it just another science fiction fantasy? Buckle up, because today, we're diving deep into the bold lunar mining dreams of the 1960s and how close we actually are to turning them into reality.
Roger, Tranquility, we copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. Okay, Neil, we can see you coming down the ladder now. I'm at the foot of the ladder. The 11-foot beds are only impressed in the surface about 1 or 2 inches. I'm going to step off the limb now. It's one small step for man, one giant leap for mankind. Tony, this is so great you can't believe it. I believe it, Charlie. Get ready, Charlie. Okay, let's go, would you, Charlie? You got all your steering and get straight. Oh, this is going to be some kind of different ride. Hippity hopping over hill and dale. Da 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 da. Hippity hopping along. One ignition. Right away, Houston. Thanks, you're good. We're going to fly. Thanks, Rod. Looks good, bud. I'll just make that flight. Roger.
The 1960s were a time of unprecedented ambition. As the United States and the Soviet Union raced to the moon, one thing was clear. Space wasn't just for exploration, it was for conquest. Scientists imagined a future where moon bases would harvest valuable elements like helium-3, a rare isotope that could revolutionize nuclear energy.
Helium-3 is produced by fusion reactions in the sun and carried through space by the solar wind. Earth's atmosphere shields us from the solar wind, but it has been depositing helium-3 on the moon for more than 1 billion years.
Some experts boldly predicted that by the year 2000, we'd have permanent lunar stations, bustling with miners extracting moon dust like it was the new gold rush.
If researchers at NASA's Center for the Commercial Development of Space in Wisconsin are successful, the first lunar settlers will also be miners.
Much like the California gold rush of 1849, space visionaries believed the moon's resources could trigger an economic boom. Except this time, the gold wasn't metal. It was helium-3, rare metals, and regolith, the dusty lunar soil filled with potential. But as quickly as these dreams soared, they came crashing down. The Apollo program's budget was slashed. The last manned mission to the moon, Apollo 17 in 1972, marked the end of an era. The grand vision of lunar mines, put on the back burner. For politicians, moon mining wasn't a priority when there were problems right here on Earth. Funding dried up, and the public lost interest. The space race had been won, but the future of lunar industry had to wait. But what makes the moon so valuable in the first place? Well, it turns out the lunar surface is rich in elements that could revolutionize technology on Earth. Helium-3, a potential game changer for clean energy, capable of fueling nuclear fusion reactors. Rare earth metals, the same materials used in smartphones, batteries, and advanced electronics. Water ice, locked in the moon's craters, potentially sustaining future human colonies. If we think mining the deep ocean is difficult, imagine an operation 400,000 kilometers away in a vacuum with no breathable air, crushing gravity and freezing temperatures. Lunar mining is a challenge unlike any other. Fast forward to today, and the dream of moon mining isn't just alive, it's accelerating. Private companies like SpaceX, Blue Origin, and NASA's Artemis program are reigniting the race for the moon. But this time, the goal is business. The Artemis program aims to establish a permanent human presence on the moon within the next decade. But what's really exciting is the involvement of private industries. Companies like iSpace, Astrobotic, and even China's National Space Administration are actively working on technologies for lunar resource extraction. Imagine automated rovers digging through lunar soil, processing minerals, and sending raw materials back to Earth or to a future Mars colony. This isn't sci-fi, it's already in development. Of course, turning these plans into reality isn't as simple as launching a rocket. Lunar mining presents massive challenges: low gravity, radiation exposure, extreme temperature swings, and the sheer cost of building infrastructure on another world. Scientists are already testing moon bases in simulated environments, but real-world implementation could take decades before mining operations become sustainable. But let's imagine a future where we do succeed. A world where the moon's resources fuel a new industrial revolution, where helium-3 powers clean energy plants, where lunar metals build spacecraft for deep space missions, and where water ice fuels rockets heading to Mars and beyond. In this future, humanity isn't just an earthbound civilization. We are an interplanetary species, and it all starts with the first shovel in the moon's surface. So was the 1960s dream of mining the moon just a fantasy? No, it was ahead of its time. But now we have the technology, the ambition, and the commercial drive to make it happen. The real question is, when the first lunar miner digs into the surface, will it mark the next great leap for mankind? Or will history repeat itself, leaving moon mining a dream for another generation? Subscribe for more deep dives into the future of space exploration.